In this video, we're going to be taking another look at angles. Hopefully you've had geometry before, and in geometry, angles can look a variety of different ways. They can be upside down, inside out. But in this video, we're going to be looking at angles that are mostly used in trigonometry. And in trigonometry, we have a certain way of talking about angles and looking at them. So this video is going to focus on angles used in trigonometry. These types of angles, I mean, they look similar. We still have a ray or a line or a segment on one side. And if this ray or line or segment were to open up, then we would have an angle. So angles are measured in degrees, and we'll talk about in the very near future how they can be measured in what's called radians as well. In this video we'll just focus on degrees. And in trigonometry, a lot of times angle measurements, if it's missing, instead of a variable like x or y, we'll usually use Greek symbols or Greek letters. For example, alpha might be in there, or beta might be used. A lot of times we'll use theta, and then in some rare cases lambda might also be used. And you'll see these symbols used in physics a lot as well. So let's get back to this angle. We had our first ray here. It's where it started, and that for our purposes will be called the initial side, or the initial ray. Initial meaning first or beginning. It opened up in this direction and it ended at this side, or this ray, and we will refer to that as the let me rewrite that as the terminal side. Terminal. So terminal means ending. A lot of times it's used in a very negative way. But try not to think of it as a negative thing. It just means ending, so where our angle ends, or the ray where our angle ends. And these two rays shared what was called a vertex. So if two rays, two lines, two segments come together and share this common endpoint called a vertex, they will create an angle. Okay, so there's just the basics. You still have acute angles, right angles, obtuse angles, and straight angles. Hopefully you know what those all mean. And we can still have complementary and supplementary pairs. The only new definition we'll need for that is that we only have positive complements and positive supplements. In a second we'll begin to see that there are such things as negative angles. And when we have a negative angle, it doesn't have a complement. It will not have a supplement. So only positive angles can have those relationships. And so there's the basics of angles there. Let's talk about how we will view angles. Let me get a coordinate plane going. Alright, so a lot of times when we draw angles in trigonometry, we'll set up a very basic coordinate plane here. We'll still have our y-axis, and we'll have our x-axis, and we'll have a positive and a negative side for each. And each of these little spaces that are formed here by the intersection are called quadrants. And we always start in the top right, so in the positive, positive x, positive y. And that is where quadrant 1 exists. And then we move counterclockwise. So over here we have quadrant 2. Down here to the left we have quadrant 3. And over here we have quadrant 4. So it starts on the top right and moves counterclockwise there. For all of the angles that we'll be drawing in the next few videos, there is this thing called the standard position. And this is how we measure and talk about angles. Standard position. A couple of things have to be true for an angle to be in standard position. The first is that the vertex is at the origin of our graph. So at 0, 0, that's going to be our vertex. And the initial ray, that starting ray, is always going to be laying on top of this positive x-axis. So we're always going to start our initial side right there. And I'll label it either I, or we'll just spell it out, initial. Okay. Now this angle can open in this direction, counterclockwise, and that would give us a positive angle. So all positive measurements are going to open from the right to the left, or in what we call a counterclockwise direction. Okay. Negative angles, we're about to find out, are angles that are measured the exact same, except that they open clockwise. So they will always start opening in a downward fashion. So hopefully you can recognize that as being negative, something that opens down. Something that opens up is going to be positive. Alright, so that's standard position. We're always going to start there. And where our terminal side ends up is going to be known as the quadrant in which the angle lies. So you're going to see probably some questions in your math book that say where does the angle lie given its measurement, or where does the terminal side lie. So we're always looking at that terminal side. So if I draw an angle, I think that's about 60 degrees or something close there. It opened in a counterclockwise fashion, so that's going to be a positive 60 degrees. And we can use a Greek letter to talk about it. So I can say that if this angle were named theta, then theta would measure 60 degrees. And my terminal side is always the ending spot of our angle. So the terminal side ended up, or is lying, in quadrant 1. So we would say the angle lies in quadrant 1. And when you answer that question, it's always where is this terminal side sitting? Okay. Alright, let's practice drawing some angles in standard position. Alright, let's try and draw 120 degrees. So I'm going to say that some angle measures 120 degrees. That's a positive angle. We're always going to draw it in standard position. So we're always going to put the vertex at the origin. We're always going to put our initial ray on top of the positive x-axis. And since we're measuring positive 120 degrees, we're going to open counterclockwise. So if you have a protractor and you have a piece of scratch paper, it would be nice to practice drawing these angles accurately given the measurement. For my purposes, I'm going to estimate them because I can't just use a protractor on top of my computer right now. So I'm going to give you something approximate, and then you can use a protractor if you would like to get the exact amount. So 120 degrees, well, we know that's past 90 degrees, so it's going to be more than a right angle, but it's not quite going to be that straight angle. It's not quite going to be 180 degrees. It's going to be about 60 degrees less. So if I draw approximately 60 degrees opening right here, you could draw that, or you can measure 120 degrees opening from the right. So that opening is what measures 120 degrees. This is my terminal side. This was my initial side. So this angle ended up in the second quadrant, or quadrant number 2. And we would say the angle lies in quadrant number 2. The angle lies in wherever this terminal side is sitting. Okay, so that's a pretty simple one, 120 degrees. I'm going to give you a challenge here. You may or may not have seen angles that measure more than 360 degrees. So for example, I'm going to call this angle theta, and we're going to try and draw an angle that measures 495 degrees. So if we start in our initial position right here, in our standard position, and we were to go all the way around our coordinate plane, that would be 360 degrees. And we're going in a counterclockwise fashion for positive angles. So there's 360 degrees, but I haven't measured 495 degrees. So I need to keep rotating here. Well, if I add another 90 to that, that's 450 degrees. And I still need 45 degrees more. So if I measure a 45 degree angle right there, 45 degrees approximately, then after my full rotation, and after another 90 degrees and another 45, then now I have a total angle measuring 495 degrees. It's a positive angle, so we're going counterclockwise. And so our directional arrow is pointed in the right direction. Our initial ray was right there. We ended up at our terminal ray. That's sitting or lying in quadrant 2. And we measured 495 degrees. Alright, so there's an angle measuring more than 360. You can do as many rotations as you want. If you have an angle measuring more than 720 degrees, that would be 2 full rotations. You'd have to draw your rotations and end up wherever your terminal side ended up after that angle was measured. So it is possible to have angles that measure more than 360 degrees. It is also possible to have negative angles. Let's see what those look like. So again, we're starting in our standard position, always starting with our initial side in the same spot. This time, let's try and measure, we'll call this one alpha just to change it up. And we want this one to measure negative 135 degrees. So the positive or negative portion of your angle measurement has little to do with the actual measurement. What it's telling you is which direction it's opening. So if it's positive, it's opening counterclockwise, and if it's negative, it's going to open clockwise. So just the normal way a clock rotates. So you still measure 135 degrees. You just maybe flip this upside down if you want to measure it that way, or you flip your protractor upside down and measure it so that it's opening clockwise. So 135 degrees is going to be greater than 90. We know we're going to rotate at least that much. There's 90. We need 45 degrees more. So if we measure a 45 degree angle right there, or if you flip your protractor over and measure just a 135 degree obtuse angle right there, and we know our directional arrow is going clockwise because it's a negative angle, then we can measure a negative angle which measures negative 135 degrees. So this angle ended up in, or is lying in quadrant 3, and it measured negative 135 degrees. Alright, so that's how we draw angles in standard position, and we can answer questions like where does the angle lie by focusing on where that terminal side is laying or sitting. And we've measured positive and negative angles, either less than 360 or greater than 360. So good luck drawing angles in standard position.